Hello everybody, today we will learn about how to perform docking experiments using PyRx software and how to visualize our results of docking using another software called Pymol. First of all, you should learn about your target protein. If it has been crystallized before, its function, exact function in the organism or in the body, human body, its active sites or other active sites on the protein such as allosteric sites. The second step, you should choose and download the best structure of your target protein. How can you select the best protein, or what is the selection criteria of the best target protein? On Google, you can type the name of your target protein. Say, we will take gyrase B of E. coli as an example. E. coli is a type of bacteria, gram-negative bacteria, and has a protein using ATP for energy called gyrase B. So you can type the name of your type protein or target protein, say gyrase P, E. coli, and end up with extension BDB to search only for proteins hosted in Protein Data Bank, for short BDB. As you can see, there are several proteins hosted in the Protein Data Bank. So how can I choose the best protein for docking experiments? As you can see, there are several results and several gyrase B hosted in Protein Data Bank. The first one that has the code of 4KFG that found in E. coli is a good one. So what is the selection criteria of good protein for good docking? The first thing is its resolution. The lowest resolution is the best. This value, 1.6 angstrom, is good for docking. The second selection criteria is the mutation. You should select a protein for docking that has no mutation. Sometimes you will find proteins in Protein Data Bank that have some mutations. This one is not good for docking experiments. You should select, as I say, proteins with no mutations. The third thing is you should select a protein that has a co-crystallized ligand or a co-crystallized inhibitor. So from this inhibitor or from this co-crystallized ligand, you can select or you can determine the active site of your protein. Okay, so the final selection criteria is that you should select a protein that have already published. This one is still under publishing and still not published yet, so we will discard it. The second result in Google search is this one that has a code of 5L3J. As you can see, it has a bit higher resolution value, 2.8 angstrom, has no mutations, and has a co-crystallized ligand, as you can see, and it has already published in 2016, but still we can find a better protein with better resolution. The third one in Google search that has the code of 4ZVI has a lower resolution, no mutation as well, already published in 2015, and has a co-crystallized ligand, as you can see. The fourth result in Google search, have retrieved a protein of the code of 6KZX. This one is the best one. Why? Because it has the lowest resolution value, 2.1, and has no mutations, and already published in 2020, and also has a co-crystallized inhibitor or co-crystallized ligand. So we will select this protein that have the code of 6KZX and download it in the PDB format, as you can see. Then we will copy the file, the downloaded file, okay, copy the downloaded file into our working place. Okay, so we have finished the first two steps. We have already learned about our target protein. We have selected and downloaded the best structure hosted in Protein Data Bank, the protein of lowest resolution that have a co-crystallized ligand and has no mutations, and finally has already published online. The third step is to prepare your docking software and visualizing software. Today we will use PyRx for docking experiments and Pymol for visualizing our final results. PyRx is among other docking software that provide a good results and already free, has no license or subscriptions. Okay, I suppose you have downloaded this software. Okay, the fourth step is to select your ligand or ligands. Sometimes you can download a group of ligands, a library or database of compounds or ligands to be tested against your target protein. PyRx recognize only library of or compounds or databases that have the SDF format. Okay, so sometimes you will find databases or library of compounds that have other formats, such as smiley formats or PDB formats or other formats. So you can use this website as an online converter that can convert your database, the format of your database, to SDF format. Okay, don't forget, PyRx cannot recognize library or databases of compounds that have formats other than SDF format. Okay, now we are ready to perform our docking experiments. Now we are ready for docking experiment using PyRx. So you should install the software in your PC or laptop and open it from here. Okay, this is the working place in PyRx. Okay, the first step is to load your protein from this icon, small icon here. So we'll find the files that you have saved before. We have saved our protein here and desktop, Zoom meeting, and remember that we have found several proteins in the protein data banks, and select the proteins that have the lowest resolution, 2.1 angstrom. So we will load this one that had the code, remember, 6KZX, this one. Okay, don't forget. So the first step is to load your protein into the working place of PyRx. Next, you should prepare your protein. How can you prepare your protein? Double click on the loaded protein, Autodog, and choose make macromolecule, as you can see. Okay, so you have prepared our target protein, and move to the next step. The next step is to load your library of compounds. You can do so from this small icon, load structure data file, or SDF. So as I said before, you should use the format of SDF to be recognized by PyRx. Okay, so we have saved our database in Zoom meeting. We will use a library of phenolic compounds, about 400 phenolic compounds. Okay, and select it. The program or the software now is loading the 400 compounds. Okay, this process may take several seconds to be completed. Okay, completed. So back up and repeat the steps we have done. The first step is to load your target protein that we have downloaded from the protein data bank. Okay, the second step is to load your library of compounds, and here we used a library of phenolic compounds that has 600 or 400 compounds. Okay, as you see. The next step is to prepare all of the compounds in this database or in this library to be docked on the target protein. So on the first compound here, right click and choose minimize all. What is the meaning of minimize? It is an energy minimization step. It is a crucial step to be performed on all compounds that will be docked on the target protein. Minimize all proteins, all compounds. Also, this step takes some time to be finished. The software now minimize the energy of all compounds in our phenolic library. And bigger databases or library will take a longer time, of course. Why do we perform this step of energy minimization? To ensure that the compound will fit inside the active side of the protein in the best conformation. So we need to make sure that all compounds have energy minimized. Okay, that's enough. We have minimized about 200 compounds. That's enough. You can do the all energy minimization for all compounds. That's enough. Okay. Next, we will prepare all ligands or all compounds for docking experiments. Okay, so on the first, right click on the first compounds and choose convert all to Autodog ligand, as you can see. This step also need time, and we will convert only 60 compounds. Okay, not all compounds, only 60 compounds, that's enough for demonstration. Okay, that's enough. So now we have our target protein loaded in the working place. We have prepared our target protein. We have loaded our library, phenolic library, and we have energy minimized all compounds founded in this library and converted it to be ready for docking on our target protein. So far, so good. So everything is ready now for our docking experiment. So we will select this wizard, Vena wizard, okay, and click to start our docking experiment. Okay, as you can see that PyRx have detected the target protein 6kzx, as you can see here, and detected only one ligand, but we have already loaded about 60 ligands or 60 compounds. So in this step you should make sure that the software has selected all the compounds or all the ligands in your library. How can you perform this? Here you can click on the first compounds and move to reach to the final compounds here, and before clicking on the final compounds press shift, so the software will select all the prepared and energy minimized ligand. Okay, now the software has selected 68 compounds. Okay, move forward to the next step. Now in this step, and just before docking, we should determine what's called the grid box or the active site on which our ligands or our compounds will be docked on. Okay, this is the large white box is the grid box. Okay, so we will resize this box only around the active site. So the question is, how can we find the active site? As we said before, depending on the co-crystallized ligand. Okay, so from here, okay, we will label our co-crystallized ligand. Click on this plus sign, okay, and move to reach at the end. Okay, this is the last icon or the last residue is the co-crystallized ligand. Okay, right click on it, display and label atoms. As you can see, okay, the software has labeled our co-crystallized ligand, so we can easily determine and resize the grid box of docking. We can enlarge the protein from this icon, full screen. Okay, click on it to enlarge, and here the grid box. Okay, and this is the labeled co-crystallized ligand. Okay, Now we will resize the grid box to enclose the co-crystallized ligand. As you can see here, click on each pole to drag and resize this box just to enclose the co-crystallized ligand here. Okay, this white labels is the labels of the co-crystallized ligand. Okay, from this side the grid box is enclosed the co-crystallized ligand very well, so we will rotate the box to see the other side. Okay, also it's enclosed the co-crystallized ligand very well. From the base of the box, rotate. Okay, also the box includes the co-crystallized ligand very well. So from each side of the grid box, now we can see that it enclosed all the co-crystallized ligand here very well. Okay, make sure to let some space or leave some space, okay, between the end of the box and the co-crystallized ligand. Okay, so the grid box now is enclose the active sites of the protein depending on the co-crystallized ligand. Now the software will search only in this area of the grid box to dock every compound or each compounds from the library on this area only to find out the best conformation that can be fit inside the active site. Okay, now we have prepared everything for docking experiments, so we will click on forward to start our docking experiments. Docking experiments and the time need for this experiments depends on the specifications of your laptop, the specification of the processor or the CPU of your PC or your laptop. Okay, this step will take about 10 minutes on average, and this time is depending on your specification of your PC or your laptop. It took about 15 minutes to finish the docking of all ligands or all compounds in the phenolic library. Okay, here we can find our results, and these columns, the most important one, that's show the docking score or binding affinity that is calculated in kilocalorie per mole. The software arrange the docking score from the highest docking score to the lowest one. Okay, so these compounds have the best score or the best binding affinity inside the active site of the gyrase B protein. Okay, now we should save the docking results and docking scores in an Excel sheet. So press on this icon, save as comma separated value CSV format. Okay, and locate the file or the folder in which the Excel sheet will be saved. Okay, zone meeting, docking results. docking results. Okay, and save. Now we will close the software and move to the last step of visualization of our docking results. I forgot to say an important step before docking using PyRx is to locate where the output files will be saved in your computer or in your laptop. Okay, so after opening PyRx and before loading your protein file or loading your ligand database or ligand library, you should locate or determine the place in your laptop that the software will save the docking outputs in it. Okay, we can do so by clicking on edit. Okay, the first thing before doing anything, before loading the protein, before loading your library, is to locate the output location where the software will save your results or your docking results. Okay, edit, preference, okay, and here browse and search the folder where the software will save your output results. Okay, here I selected Zoom meeting and click OK. Okay, then close the software and reopen it to load your protein target and your library and doing your docking experiments. Okay, don't forget, before doing anything or any docking experiment, is to locate the place in your laptop where the software will save your output results. Okay, so we have finished our docking experiments by PyRx, and now we will visualize our results using Pymol software. In PyRx, we have located our output folder in this folder, Zoom meeting. Okay, so we will open it and we will find a new generated file or folder called macromolecules. In this folder, PyRx have saved our docking results. As you can see, these are our docking results, all of these. The first one that have the label of 6-key ZX is our target proteins. Okay, and the remaining files are the conformations of each ligand or each compounds in the phenolic libraries that we have used. Okay, so, and we can also find the Excel sheet that arrange the docking score of all compounds in the phenolic libraries, from the highest docking score to the lowest one. Okay, normally we will use a cutoff of -4 kilocalorie per mole as a cutoff. So all of these compounds that have a docking score value above -4, as you can see, we will consider them as the best scoring compounds, and this compound is the best one among all other ligands or other compounds. Okay, we will open macromolecules folder. Okay, and open the protein file. Right click on it, open with, and choose Pymol. If you had already installed Pymol software in your laptop, we will see it indexed in right click, as you can see. Right click on it, open with, and Pymol to open the protein file. Here our protein file, and this molecule is a co-crystallized ligand. As you can remember, we selected a protein target, Resize B, that have a co-crystallized ligand. But now we don't need this ligand, so we will left click on it, and on this icon, action, selected action, remove atoms, to remove the co-crystallized ligands. Also these ions, we don't need them, action, remove atoms. Now the protein is free from any co-crystallized molecules. Okay, now from file, choose open and move to the folders of docking results, desktop, Zoom meeting, okay, macromolecules, okay, and from the Excel sheet we will know the molecule of the best score, this one, of the molecular formula of C10H10O3. Okay, so we will looking for C10H10O3, 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 this one. Okay, and open. Okay, now the compounds have loaded in the protein, as you can see, and take this orientation. To find out the interactions, the molecular interactions between this ligand and the active site of the protein, okay, we will click on A here of the protein, A, find polar contacts to any atoms, okay. Oh, here we can find that the phenolic OH here form a hydrogen bond with the active site of the protein. So these compounds that have a docking score of -4.8 is the best ligand or the best compounds in the phenolics library that can fit inside the active site of the Resize B protein. It's worth noting to say that this value of binding affinity 4.8 minus 4.8 kilocalorie per mole is not good enough to consider these compounds as a promising inhibitor for this protein or for Resize B. The best or the cutoff of best inhibitors should be above -7 kilocalorie per mole. Okay, so this value -4.8 is too small to be considered for further working. Okay, but this our results with this library of compounds and this target protein. Okay, this is the whole workflow of docking and visualization. I hope that you learn how to perform docking experiments, how to visualize your docking results using Pymol software. So please perform your own docking experiments using the library that Dr. Mustafa have sent to you, and any note or any problem you will face during your assignment. We will discuss them in the next meeting, Zoom meeting, next Thursday inshallah. Okay, nice to meet you, and looking forward to our meeting next Thursday inshallah.